Goal: derive the BFSS matrix quantum mechanics from 10-dimensional n equals 1 super-Yang mills by dimensional reduction. We start in 10 dimensions with 1 time and 9 space directions. The Clifford algebra in equation 1 fixes the gamma matrices, gamma m, and sets our spinor conventions. Begin with a 32-component Dirac spinor. Imposing Majorana, reality, and Weil, chirality, leaves 16 real components, i.e., 1/4 of the original real degrees of freedom. The full 10-dimensional action is in equation 2. It contains the gauge field strength and the fermion kinetic term built from the covariant derivative d sub m acting on the spinor psi. Dimensional reduction. Set all spatial derivatives to 0 and reinterpret the spatial gauge components a sub m as adjoint scalar matrices x sub m. After this step, the theory depends only on time, and its structure is bosonic kinetic term, quadratic in the time derivative, proportional to d0 x sub m squared. Bosonic potential, quartic commutator squared, built from x sub m, x sub n, and positive definite in Euclidean signature. Fermion kinetic term, first order in time, proportional to psi dagger d0 psi. Fermion matrix coupling, linear in x and bilinear in psi, of the form psi dagger gamma superscript m times the commutator x sub m psi. This is precisely the BFSS matrix quantum mechanics in one-time dimension. The original Lorentz symmetry SO of 1,9 reduces to a global rotational symmetry SO9 acting on the 9 matrices x sub m. Supersymmetry remains maximal for quantum mechanics with 16 real supercharges, and also a local UN gauge symmetry. For calculations, it is convenient to use a block gamma basis. Gamma 0 equals I times sigma 2 tensor identity, and gamma m equals sigma 1 tensor gamma m, with sigma 1 and sigma 2 Pauli matrices and gamma m Euclidean 9D gammas. With the Weil projection and the Majorana condition, the fermion reduces to a 16-component spinor psi shown in equation 9. In terms of this spinor, the BFSS action takes the simpler form given in equation 10. When needed, perform a Wick rotation to Euclidean time, t goes to minus it. This renders the bosonic sector positive definite while preserving SO9 and the 16 supercharges. Correspondingly, the Feynman probability amplitude turns into a Boltzmann weight. The Euclidean formulation is the one used on the lattice in conjunction with the Monte Carlo method. To summarize, starting from the 10-dimensional action in equation 2 and the algebra in equation 1, set spatial derivatives to 0 and rename a sub m as x sub m. The resulting one-dimensional theory contains a quadratic bosonic kinetic term in time, a quartic commutator potential, a first-order fermion kinetic term, and a fermion matrix commutator coupling, exactly the BFSS matrix quantum mechanics.